Hi everybody, today is Tuesday the 15th. Sorry I was not in class today. I'll be back tomorrow. Today you took your Unit 2 quiz, and now you should be sitting at home nice and comfortable with your composition book out. This is our second flipped classroom. The first one you just had to watch. You didn't have to write your notes. But today what I'm asking you to do is take notes just as if you were in the classroom. Anything I write down, you write down. And if there's a question, just make a note next to the problem that you did. And you can ask questions tomorrow. At any time, you can pause this. If I happen to talk too quickly or work through the problem too quickly, you can pause it and rewind it and play it. Or not rewind it, hello. You can just replay any section of this that you need. Okay, as you can see, we are taking notes on systems of equations, which we've already done one method. We've already graphed. Remember, a systems of equations is where I have two equations together with graphing, we graphed on an coordinate plane, and the solution is where the two intersect. Remember, if they are intersecting lines, they're going to intersect at one point, and they have one solution. If they are parallel lines, they have no solution because they don't ever intersect. And if they are coincidental lines, they have infinitely many solutions because they are the same line. Now, a lot of times when you're graphing, you may not be able to find that exact point. You'll see that they intersect, but it may be at a fraction, which, as you know, you can only estimate that. So our second method that we're going to use is called substitution. And it is just kind of like what you're used to doing. You're substituting a value in for something else. So in example number 1, remember, you are writing everything that I write down. You have two equations. Now, if you wanted to, you could solve this by graphing. You could graph because both of them are in slope-intercept form, but that's fairly large numbers for your y-intercept. So substitution would be the more appropriate here. Now, substitution says I'm taking one value and substituting it in for another. So if you see both are set equal to y, so I'm telling you that y is 12x plus 60. I can take that 12x plus 60 and substitute it into my second equation for wherever y is. And when I do that, I get just a variables on both sides equation, which we've been doing forever. Get rid of 60. Get rid of 10. So 2x is equal to 20. Divide by 2. So x is 10. Let me get this out of the way. I apologize. Okay. So now we found the x-coordinate. And as you know, we need to find a point, and a point consists of an x and a y. So now I take x, and I can substitute it back into either equation to find your y. And I get 180 for y. So the point where these two will intersect is at 10, 180, which again, I would not want to graph that. Okay, number 2. Okay, I have two equations. Both are in slope-intercept form. I don't want to graph them, but you want to make sure one of them is solved for y. If it's not solved for y, then you're going to have to manipulate and rewrite the equation so at least one of them is. Okay, well, I'm going to change it up, and I'm going to say, you know what, I want to take this and I want to substitute it up there, giving me the equation 8x plus 150 is equal to 10x plus 120. Solve it just like we did the other one. And you get negative 2x is equal to negative 30, so x is 15. That's just the x-coordinate. Now we got to plug the 15 back in, and I can plug it in either one. I'm going to plug it in the top one. Just changing it up to show you that it really doesn't matter. 10 times 15 is 150. 150 plus 120 is 270. Next, example number 3. Now, if you feel pretty confident on what we're doing, after I put the next equation up, you can stop the video, you can pause it, work it yourself, and then see if you get the right answer. Or you can just do it with me. Okay, so now you see that I have one equation solved for y and one equation in standard form, 3x plus y is equal to 10. Well, obviously, I could rewrite this one and solve it for y, but there's no point. If this is my y, I'm taking all of this and plugging it in right there. So now, instead of me writing y, I'm going to write x plus 2. Collect like terms, and then just solve. And I hope you see why we have worked so much on equations and multi-step equations, because we are using them throughout the units. So again, my x is 2. I need to plug it in to find y. You can plug it in either equation. Obviously, the top equation is the easier to do. And 2 plus 2 is 4. Number 4. And again, I have this one is set equal to y, so I'm going to take this and plug it in there. And that gives me 3x plus x plus 5 is equal to negative 11. So that gives me 4x plus 5. Get rid of 5. So 4x is equal to negative 16. Divide by 4. So if x is negative 4, I plug in negative 4. Y is 1. Okay, example number 5. And now I have y is equal to 3x plus 8, and then I have 8x plus 4y is equal to 12. My top equation is solved for y, so I'm going to take all of this and plug it in there. But now be careful, because what do I have in front of that? A 4. And hopefully you already are saying, you know what, I've got to distribute, because it's 4 times all of what y is. And now, again, this is just a multi-step equation. Distribute. Collect like terms. And then get rid of 32. When I subtract, I get a negative 20. Divide by 20. So x is negative 1. Okay, and remember I need to plug in negative 1. So that gives me negative 3 plus 8. So y is 5. And my solution is negative 1, 5, which again means that's where the two linear functions intersect. Okay. We will practice more in class tomorrow with this. Hopefully you've written all this down. If there's anything that you had any questions, go back and re-watch it or make side notes, and we will talk about it tomorrow. Hope you guys have a great night. And again, hopefully you enjoyed sitting on your bed, just chilling. I'm taking these notes, and that's about it. So technically your homework, I believe this recording was about 10 minutes. So you had 10 minutes of math tonight. Not too bad. I will see you guys later. Y'all have a great night.